So, hello everyone. I'm Howard Zhang from ARM. So today my presentation topic is about building bridges contributing to KubeVirt and enable multi-arc support. I had made contribution to several open source projects, include Kubernetes, Golang, KubeVirt, gvisor, and many others. So this is today's agenda. Firstly, I will give you a general introduction of what KubeVirt is. Then I will talk about the key process for contribution to the KubeVirt project, include what we do, how we do, and the challenge we meet. And lastly, I will talk about the best practice for building relationships with the community. You know, when we contribution to the open source community, sometimes the most challenge is not about technical, but about communication. So build a good relationship with community is very crucial. So what KubeVirt is? You may know about Kubernetes. Kubernetes is an open source container orchestration system used to automatically deployment, scaling, and management of the containerized workload. But in a company, they may have both containerized workload as well as virtual machine workload. So KubeVirt provides a Kubernetes native way to run virtual machine over the Kubernetes. As you can see in this image, after you deploy Kubernetes and as well KubeVirt on top of it, you can manage both container workload as well as VM workload in a uniform platform. This simplifies infrastructure management for a company, also reduce their management burden. And this project is led by Red Hat, and it is a CNCF project. Now it adopted by over 30 organizations, include NVIDIA, Microsoft, and ByteDance. This project also serves as a foundation for solutions like Red Hat OpenShift, virtualization, and SUSE Harvester. And this project became a CNCF incubating project in April 2022 and is currently in a graduation process. Here's the main contribution we made to the KubeVirt project. The first one, we enable KubeVirt on ARM64 hardware, and the initial patch series submitted on May 4th, 2020. It's 5 years ago. And secondly, we enabled the cross-build tooling and released multi-arc KubeVirt images and binaries. We also added ARM64 specific unit and E2E test, and we supported E2E testing in a Docker environment. I will illustrate this part later. And the fifth, we integrate ARM64 hardware into KubeVirt CI infrastructure and run ARM-related tests in the PR submission workflow. And lastly, last year, we enabled the KubeVirt sub-project, containerized data importer on ARM64. This is a very important sub-project for KubeVirt because KubeVirt uses it to create virtual machine image and storage volumes. So let's start with functional verification and enablement. When trying to enable a new project on ARM, the first thing is always make sure this project functional correctly on ARM hardware. So usually we will review the code base to understand the functionality, the architecture of the code, and the component of this project. And then we can identify the key enablement gaps for prevent it running on ARM64. After we know the gaps, we can break down those gaps into different issues. As we cannot solve all issues at once, so we take an incremental approach to solve those issues. And here is a link to show how we break down the task. Let me see how to. Maybe I need to exit. Let me see. Yeah, as you can see in this issue, we break down the task into several, the gap into several subtasks. We have some title like make KubeVirt on ARM64, and cross-building and KubeVirt CI, and we create PR for each subtask. And then the maintainer will review your plan to give some comments on it. Once you get some approval from the maintainer, you can start to write some draft code. Okay, let's go back to the presentation. Okay, the main challenges we're facing in this step. The first one is the virtual machine XML configuration is different between x86 and ARM64. Some devices that support on x86 may not support on ARM64. Also, some feature or flag that is CPU architecture specific. So we have to carefully identify and verify those differences and explain them to the community. The second one is beyond the configuration, we also have some additional differences need to be discovered, such as memory footprint under UFI boot. On ARM64, when we boot a virtual machine via UFI boot, QEMU will reserve 120 megabit memory for EFI firmware. This is different on x86. After we have, once we have a solid understanding of the difference, we can carefully design how we introduce the architecture-specific logic in the code base. This requires close cooperation with the core maintainers to ensure the change were well aligned with the project's standard and the future maintainer ability. The next one is testing enablement. So for our open source project, testing is very essential, very important, because a contributor is from everywhere. So if you don't have a well-designed and well-covered test, it's hard to maintain the code quality. Usually there are 3 levels of tests in an open source project: unit test, integration test, and E2E test. For KubeVirt project, we have unit test and E2E test. So for unit test, as we introduce some CPU arc specific code, so we have to make sure all the codes are properly covered. In order to achieve this, we refactor the test framework, introduce CPU architecture as a configurable parameter in the test framework. By doing this, we can verify if the code is correct on ARM platform, even run those tests on x86 hardware. And for E2E test, end-to-end test, we have more challenges. The first one is test virtual machine image build. KubeVirt use many virtual machine image to verify its functionality, like Ceros, like Fedora, like RPi image. Some image is pre-installed with some tools, like net tools. So before, those image were built manually or use some script or external tools that only support on x86. So we have to rewrite those scripts, build the build process, and find the architecture-specific dependence. And another big challenge is E2E test environment. So on x86, it uses nested virtualization to do E2E tests. Basically, they will start up 3 virtual machines, and in these 3 virtual machines, they deploy Kubernetes cluster and deploy KubeVirt on the Kubernetes cluster. And they will do the E2E tests within this environment. However, on ARM64, we do not support nested virtualization. We have to find another way to isolate the test environment. Thus, we can run the parallelly run the E2E test on a bare metal server. And finally, we choose the Docker in Docker environment. Here is a brief introduction of the nested containerized environment. As you can see in this image, this box is a bare metal server. We will deploy a Kubernetes, one node Kubernetes cluster in this bare metal server. And we can send the test job to the Kubernetes cluster, E2E test job to the cluster. And then this Kubernetes will create a bootstrap pod. It's the outermost container. And within this container, we use a tool named kind to create a Kubernetes cluster. And on it, we deploy the KubeVirt component. Now we have an isolated E2E test environment, and we can run E2E tests on it. And we'll also deploy an image registry on it to serve the local test images. And we also containerize the build process in the Bazel builder image. To make this environment work, we have made many programs like the file system access program, network issue, pod privilege issue. However, after persistent debugging and refinement, we were able to make this scenario stable and functional. So after the functionality is confirmed and the test set up, the next step is release. And some contributor or open source community infrastructure may not have access to ARM64 hardware, so cross-build is necessary. So basically, cross-build enable cross-compilation of binary and container image. And we also have to develop supporting tools and script to facilitate this step. KubeVirt project also meets the same issue. They don't have ARM64 hardware at first. So we have to help the KubeVirt project to do cross-building. Here is the main challenge. KubeVirt use Basel build. The Basel is a relatively complex build tools. So it's really so if you want to do any amendment, modify or add some new feature to the build process, you need to have a good understanding of Basel inner mechanism. Otherwise, you can't do anything. So in KubeVirt, it contains Golang code and C code. So we have to introduce the cross-compiling toolchain into Basel. It's x64 long Linux Gong toolchain into the Basel. So as I said, the Basel is relatively complex. And maybe for some maintainers, they have no idea what cross-compile is, or they have little background on the Basel building. So in order to make this process easier, I developed a simple demo to illustrate the cross-compiling use Basel. This makes the maintainer can review and validate the cross-compiling code before we actually provide our implementation. And another issue is that in KubeVirt, it installed a lot of RPM package in their KubeVirt component. We need to find an effective way to manage the architecture-specific package. Its download, its version, its sum check, and its repository resource. After discussion with the community, one of the maintainer provide a solution on this, and it integrates into the build flow. Okay, the last part of our enablement is integrating ARM64 testing into the KubeVirt CI/CD pipeline. So firstly, we need to integrate our ARM64 machine into the community CI infrastructure. We need to configure the environment server with community CI standard, include OS, software version, and system setting. And then we have to verify if our if ARM-line test is stable or not. So we following four steps. Firstly, we verify if the test works well in our local machine, and then we create a periodical test for make it run for a few weeks to see if it is stable. Once it is stable, we can try to integrate the test into the community's CI lines. But now the result is hidden from public. And if those tests keep passing, the community will publish the test result to user. And you can see in this chart, currently we have 3 online tests in the pre-submit CI/CD pipeline. We have the cross-compiling test is running on x86 machine, and we have unit test and E2E test running on ARM server. Okay, this part is about the best practice for building community relationships. As I said before, sometimes the most challenge when we contributing to the open source community is not about technical, it's about the communication. So build a good relationship with community is very, very crucial. So the first one is maintain a clear and transparent roadmap. For the open source project, when they accept a new architecture in the project, they prefer to see a long-term maintenance of the new architecture rather than you just submit PR to support the ARM64 platform only. So if you give the community a clear and transparent roadmap and plan, they will have confidence to accept. They can say you will have a long-term maintenance of the online, and they will have confidence to merge your patch and accept the new architecture. The second one is actively participating in community meeting and discussion. And this one is especially useful for if you are a newcomer for a project. It can increase the mutual understanding between you and the maintainers. Also, you can show your technical ability to them. The third one is respond promptly to questions and issues arised by community. And we also actively monitor ARM-related issue and offer support. The last one is very, very important. We actively offer reviews and ask thoughtful questions in PRs. This is very important in open source project. When you provide help to others in PRs, your contribution are more likely to receive prompt review in return. Okay, that's concluded my presenting on how we make contribution to the KubeVirt project. Include what we do, the challenge we met, and the collaboration spirit we need to make a contribution to open source community. Okay, thank you. So, any questions?
I have a question about the timeline. So could you share the timeline about how long it takes about for the proposal, for the implementation, and for the communication to merge the code? Yeah.
Yeah, it's a good question. As you can see, the first submit was on 2020. May 1st, but we try to get those patch merged, it take almost 1 year. Yes, because you have to convince the maintainer to accept ARM64 platform. They say why? Why we need new architecture? Yeah, and also when you initially submit your code, maybe some maintainer think the way you put the ARC-specific code is not ideally. They will keep asking you to amend your code. And for the KubeVirt project, once we get our initial patch merged, the following process is very smoothly because we could build a good relationship with maintainer. I think for those parts, this part take 1 year, the first patch merged, and the following part takes another year. Yeah. But it's quite depends on different projects. Some projects, they really like accept newcomers or new architectures, so they will, the patch merge will be easy. Yeah. Okay. Any other questions? Okay, thank you.